Hello, my name is Matt Thompson, Vice President of Program and Market Development for ISTA, the International Safe Transit Association. It's my pleasure to participate in the 2023 Korea Sustainable Packaging Forum. My presentation today is focused on ISTA's Responsible Packaging by Design process, also referred to as ISTA RPbD. The goal of RPbD is to help our members design packaging with sustainability in mind, while also having a full understanding of the implications of cost and packaging performance. RPbD enables the packaging designer, the packaging engineer, to create responsible packaging and engage with a vertically integrated team earlier in the larger product development process. I'll start by taking you through a brief overview of ISTA. I'll provide a walkthrough of ISTA's current Responsible Packaging by Design guide. I'll talk about work that's being done right now to revise this ISTA standard. Then I'll speak to how to approach the challenge of working together to consider packaging earlier in the product development process. I'll talk about project scope. And finally, I'll finish by emphasizing how important strong objectives and metrics are to the success of packaging design and development projects. Okay, first about ISTA. The International Safe Transit Association is an organization which provides a place for those in packaging design, testing, and supply chain to work together to solve problems and open new opportunities of common interest and benefit. ISTA is a member-driven, nonprofit organization with leadership around the globe whose mission is to empower those in the packaging, testing, and supply chain industries to minimize product damage during distribution as products are shipped from manufacturing all the way to their customer's front door. ISTA helps our members optimize global resources through effective packaging design. ISTA provides an understanding of hazards in the shipping environment, including shock, vibration, compression, temperature, pressure, and more. We work to bring transparency to the global supply chain. ISTA certified experts work to simulate distribution of packaged products of all shapes, sizes, and weights in ISTA certified labs all around the world. ISTA membership includes more than 425 leading brand owners and retailers, as well as over 625 packaging suppliers and carriers in more than 40 countries around the globe. ISTA certifies more than 650 package testing labs and more than 850 ISTA packaging dynamics professionals through our online, live virtual, and in-person training and certification programs. At the core of our association is distribution environment research. In just the past 5 years, ISTA has invested more than $1.5 million in research of supply chains around the globe. Right now, for example, we have ongoing or just completed research projects in North America, Europe, India, and China, including research for products crossing the world's oceans, roads, rail systems, and by air. ISTA is working with volunteers and other research teams to collect shock, vibration, compression, temperature, and location data to better understand what's going on when products are shipped to and from all corners of the globe. Sources of investment for research and monitoring include our core ISTA budget, as well as ISTA's Advocate Research and Value Delivery Program, as well as ISTA's Education Foundation, which provides grants for university students doing their own research of the global supply chain. Next are ISTA's design tools, from our Find a Lab and Service tool on ISTA's website to our digital test planning and reporting system called PackSite. ISTA continues to provide packaging designers and engineers with rich sets of tools alongside the data they need to design and then test packaged products as they work to manage the world's precious resources. ISTA provides 22 packaged product test procedures, including our most popular 6 Series Amazon.com SIOC test, alongside of Amazon.com's overbox test, and then ISTA's 1A, 2A, 3A, 3B, 3E, and many more test procedures. It's worth mentioning that ISTA just released a brand new test procedure designated as ISTA 3L, which is a generalized e-commerce retailer fulfillment test. The origins of ISTA 3L reach back many years. ISTA is always researching and monitoring the global supply chain to validate and verify existing and develop new test standards. ISTA provides education programs via our online self-study platform on our ISTA.org website through live virtual events and live in-person training options. From our foundational training and support of our ISTA Packaging Dynamics Professional program to our more advanced courses focusing on distribution, environment, data collection, and analysis, and now our brand new CC 101 Principles of Cold Chain Packaging course, there are many options for both ISTA members and non-members alike. ISTA offers certification for people, places, and packages, meaning you can invest in yourself and your organization to become an ISTA PDP, a Packaging Dynamics Professional. Or if you're in the temperature-sensitive packaging and testing space, then you can work to become an ISTA Certified Thermal Professional. ISTA also offers certification for package testing labs. And you can even get your packages certified to what we refer to as ISTA Transit Tested, which elevates your product brand and gives greater consumer awareness to your efforts to minimize product damage and meet your goals for sustainability. Finally, ISTA is proud of its Forum and Packaging Symposium events. ISTA's signature TransPack and TempPack Forum events are held each spring in the US, while our European, China, and Asia Pacific events are offered later in the autumn each year. All ISTA events feature technical presentations and opportunities for networking for packaging, testing, and supply chain experts around the globe. Altogether, ISTA works hard to bring a full suite of programs and services to its members. There's something for everyone. We welcome you all to participate and share your expertise. Next, I'll provide some information about the current version of RPbD. The purpose of my presentation is to show you how ISTA's responsible packaging by design process can be used to design and develop packaging earlier in the product development process. Packaging by design, which is often referred to as RPbD, is a voluntary ISTA global process standard focusing on the design, testing, and qualification of what we refer to as responsible packaging. ISTA created RPbD to provide the packaging professional with a detailed approach to packaging design and development, looking to improve the sustainability of packaging throughout the global supply chain. RPbD recognizes the importance of managing our global resources while emphasizing that every time a product is damaged in transit, it is a sustainability disaster. Product damage during shipment leads to tremendous waste, from the extra packaging and energy required to return and replace the product to the resources required to resell, recycle, or dispose of the damaged product. The RPbD process helps organizations solve problems together as a team, working project by project, focusing on sustainability, cost, and performance objectives. The RPbD guide is 112 pages long, with 32 pages of design and development fundamentals, 3 pages covering definitions of terms, and a broad appendix of plan and process templates and examples. After an introduction to general concepts, the guide outlines responsible packaging by design as a step-by-step process. There are 8 steps to the current RPbD process. Each is critical to the success of project objectives. The first is to establish the scope for your project. Step 2 is to define limitations or boundaries along with relevant metrics. These first 2 steps are important as you set expectations and focus on defining what makes your projects a failure or, more importantly, a success. The project team needs to establish goals that you can quantify. I'm sure you already know about the importance of setting goals that are specific, measurable, achievable, relevant, and time-bound. Step 3 reminds us to assess the impact of any current designs that may be in place. Sometimes you're preparing to roll out a brand new product that doesn't already have packaging, or working to optimize the packaging for an existing product. It's always important to draw from your expertise and the experience of your team members. Experts will tap into their experience and know where and how to start. The remaining steps 4 through 8, shown here in a lighter green color, focus on determining the impact of different design options, then prioritization and selection of the best action, then prototyping and validating which packaging design should ultimately be recommended, documented, and then implemented. ISTA's current Responsible Packaging by Design guide recommends 14 categories for metrics focused mostly on sustainability in packaging. RPbD includes definitions, examples, and templates for 21 different plans, scopes, charters, SOPs, and reports, all of which could be critical to project success, especially for development of packaging for products which are regulated by industry or government organizations. Even if your design and development project is related to projects that are not regulated, success may still hinge on having some or many of these plans, scopes, charters, SOPs, and reports in place and ready for review and approval by stakeholders all along the way. The experts that developed the ISTA RPbD process wanted to share how and why they've been successful in their careers. ISTA looks to help our members sharpen their expertise. Getting packaging designers, engineers, developers involved early in the product development process often requires knowledge of key considerations along the way. Okay, on to the next topic. I'd like to give you a preview of some of the work that's being done to update the current version of ISTA's RPbD process standard. ISTA has formed a work group of experts to revise and expand our Responsible Packaging by Design guide. These 9 experts currently work for product brand owners, packaging material suppliers, and consulting firms. They've been working for the past 9 to 10 months to add to and update the guide. ISTA plans to release the update to our members next year in 2024. The balance of my presentation here today will touch upon some of the concepts and recommendations contained in this revision. One of the first improvements the work group is making is a clarification to some of the 8 steps in the process. Step 1 is being updated to remind ISTA members to define the design and development team right up front along with the scope for the packaging design and development project. Step 2 now emphasizes the importance of defining project objectives early in the project alongside of measurable metrics. You'll also see a mention of objective and metric libraries down below the updated Step 2. I'll share more about these later in my presentation. One of the RPbD workgroup's primary deliverables is a much stronger library of objectives and metrics. Steps 3, 4, and 5 now clearly speak to the assessment of current designs, then the drafting of one or more new designs, and the assessment and comparison of the new to the current design. Step 6 reminds the project team that it's time to prototype and validate. This is where the team confirms sustainability, cost, and performance of the new designs. Step 7 gives a chance for the project team to apply team expertise to decide if one or more of the new designs needs to be updated before moving forward. The purpose of this important step is to determine if more design or testing needs to be performed before moving forward. The final step in the process focuses on implementation and staying in touch with team members and stakeholders, tracking performance versus project objectives and metrics into the future. The process reminds project team members that tracking metrics helps confirm success or failure at the end of a project. Tracking success shows the larger product development team the value of including the packaging team early in the larger product development process. Next, I'll speak to how packaging and product development teams work together and how there can be some improvements to the process. Let's start with a general list of steps involved in the typical product development process. These include conceptualization, development, prototyping, pre-production, manufacturing, quality control, and optimization. This last optimization step can go on for many months or even years. It may ultimately lead to repeating this process all over again. In small companies, project teams may also be small, and each member of the team may have multiple or many responsibilities. For many of us, however, product and packaging development can include a larger team of experts from all different departments inside and outside the company. In this example, I'm showing two different packaging teams. The first working at a consumer packaged goods or fast-moving consumer goods company, and the second example at a company developing products in the industrial, electronics, automotive, home goods, or biopharma sectors. The combination of experts from different parts of the company or channel can be different for different categories of products. Project team members can include R&D, marketing, scientists, engineers of many disciplines, manufacturing, production, and quality control. There are others that aren't even listed here. The team can include management, purchasing, accounting, and more. For many CPG companies, as in the first example here, the package is an integral part of the product. The package is on the shelf representing and communicating the brand along with the features and benefits of the product. In such cases, the packaging design and development team may very likely be regularly included early on or right from the very beginning of the product development process. In other parts of the industry, like in the second example here, for non-CPG products, this is often not the case. Packaging, especially distribution packaging, is often not considered early on in the product development process. Packaging, especially for unitization or e-commerce distribution, is often an afterthought. The packaging department or the packaging supplier may be brought into the product development process late in the game, sometimes not till pre-production in the few months or weeks before the products need to be shipped out the door in quantity. This delay is not recommended. Packaging teams need to do everything they can to prevent this from happening. Distribution or transit packaging can be costly and have a significant impact on the environment. As companies work to use life cycle analysis tools to meet extended producer responsibility and net zero goals, waiting to consider distribution packaging can jeopardize success and lead to the missing of important cost and sustainability targets. Worse yet, it could lead to product damage, which is often the worst thing that can happen to a company's reputation and general bottom line, on top of being a disaster for the environment. More on that later. ISTA's responsible packaging by design process emphasizes the importance of and helps packaging teams get involved earlier in the product development process. This is the busiest slide I have for you today in my presentation. The purpose here is to emphasize that working together with development teams, the packaging team process, which is shown down below at the bottom of the slide, should be repeated over and over as you go from product conceptualization and development on through to prototyping, pre-production, production, quality control, and optimization. In order to minimize cost and the impact of packaging on the environment, the RPbD process shows the importance of involving the packaging team early and often. Next, I'd like to focus on project scope and how the packaging designer developer uses RPbD thinking, how the packaging designer needs to understand how he or she best fits into the larger product development process. Back when I was in college at university, in my Packaging 101 Intro to General Concepts of Packaging class, the professor used a simple math metaphor to explain how to think about the product, package, and the distribution environment. I've seen this repeated in presentations many times over the years. I'd like to take you through a brief discussion and provide my expanded version of this concept. To be clear, rather than just product plus package equals the environment, I would clarify that it's the robustness of the product, meaning the ability of the product to be structurally, functionally, and aesthetically well made, that is combined with the performance of the package that must survive the total of all hazards in the distribution environment. All the hazards the packaged product will experience from when it leaves the manufacturer and travels all the way to the door of the customer. Those distribution environment hazards can be atmospheric, such as temperature, humidity, pressure, and odor. The hazards can also be physical, such as shock, vibration, compression, abrasion, puncture, and require a unit load to be contained and stable. The distribution environment has what we also refer to as modes. These are typically ocean, air, rail, and over the road. Vehicles are also considered in RPbD. There are hundreds of different types of vehicles carrying packages around the world. RPbD also recommends considering how packages are handled. In the end, there end up being hundreds of different, if not thousands of different combinations of different automated, mechanical, and manual handling methods and equipment. We can look back to our metaphor to understand that when the robustness of the product and the performance of the package don't add up to the intensity of the total hazards in the distribution environment, you can or will have product damage. This situation can be addressed by increasing the robustness of the product, which is often preferred, but not typically something the manufacturer wants or can do. If instead the quality or quantity of the packaging is insufficient, then packaging design is inadequate and there is too little packaging. Looking at a different example, if for the same product, the packaging has an abundance of performance through a superior design or high quantity of packaging, you could say that there is too much packaging. Some refer to this as additional or over packaging. I'll pause to comment that sometimes over packaging is part of the requirements and or the objectives of a packaging development project. When the product has, for example, a very high value, then the manufacturer may require a high level of assurance. That said, in most all cases, overpackaging is looked at as wasteful and not a good result for your packaging design and development project. So you've already figured out my simple point that the packaging designer or packaging engineer needs to have a strong understanding of the distribution environment. And then through cycles of design and testing and eventually feedback from channel partners and end customers, the design and development team applies their expertise as they seek a balance between too little and too much packaging. Expert packaging designers will ask the right questions to understand the distribution environment and consider asking the product development team to improve the design of the product to minimize the need for packaging. In the end, this may be the best use of resources. Then again, if the focus is on the design of the packaging, experts learn how to recognize under or over packaging right from the start of projects, and then apply the most appropriate distribution test procedures to validate and confirm performance. There's a lot on this chart, but this is a common way to look at the balance of too little packaging, which can lead to product damage, and product waste, which is shown on the left side of this chart, versus too much packaging and therefore packaging waste, which is shown on the right side of this chart. The important point here is that high product damage rates, which are shown on the left, are most harmful to the environment. For a strong majority of the products in the market, the carbon footprint of the product far exceeds the carbon footprint of the package. In many cases, it exceeds by 1 or more orders of magnitude. Damage rates in shipping of 5%, 10% or more are disastrous for the environment. High damage rates do happen. Optimization of your packaging is critical for reasons both of cost and sustainability. The objective for packaging development can and should be to achieve a balance and be just right in the middle of this chart. It's no surprise to anyone that we need to optimize packaging performance while minimizing effects the packaged product has on the environment. My final point here in this section is that there's another way to look at the simple metaphor of product plus package must equal the hazards of the distribution environment. Relating this concept back to my earlier points about working together with a wider product development team, the packaging designer needs to know much more than just the total of all hazards in the distribution environment. Before the packaging design and development team begins the project, it's critical for the packaging professionals to know more about the product, to know about the customer, and the targets for cost. Packaging professionals need to know about materials used to manufacture the product and the package. They need to know about regulations that apply to storing, transporting, using, recycling, and disposing the product and the package. They need to know details about sustainability and the needs of marketing. They need to know about manufacturing and production, how the product and package come together via packaging equipment, and how to get the packaged product out the door and on the way to the customer. The packaging designer must know about the supply chain. It goes on and on. So the equation here is much more complicated than what was shared with me back in my Packaging 101 class at university decades ago. There's a lot to consider. Finally, to back everything up I've just discussed, I'll end with some comments about the importance of clear project objectives and selecting and tracking project metrics. The complexity I just pointed out needs to be qualified, quantified, and tracked in a good packaging development plan. So how do we do that? As mentioned, the responsible packaging by design process includes methods to address these challenges. Having strong objectives and metrics is critical. Building a team of experts will increase the probability of success. The work group working on the revision to RPbD has developed what we refer to as pillars and objective metric categories. These categories fit into 6 pillars focusing on transit, the product, cost, performance, sustainability, and purpose. Each objective metric category contains dozens of metrics. The RPbD process encourages your development teams to select objectives and metrics and describe appropriate actions for each. By actions, I mean that it's what you want to do. Is your objective to modify, improve, add, increase, reduce, phase out the objective or metric? Once objectives and metrics are selected, the entire team will be able to better understand, monitor, manage, and apply their expertise to meet and perhaps eventually exceed goals of the project. Using the same language and description of objectives and metrics over time allows your company, your organization, along with your supply chain and sales distribution channel teams to analyze and compare metrics over time. Over the duration of the project and even into the future of many projects for years into the future, you'll be able to compare and contrast and track progress towards even bigger goals. Here's an example of the objective metric category 5.6 for greenhouse gases. The Environmental Protection Agency in the US offers 27 different metrics for greenhouse gas equivalents. They offer a calculator for conversion between these metrics, including values in imperial and metric units. These are examples of metrics in the revision of the Responsible Packaging by Design guide that ISTA will release next year in 2024. So I hope you found this overview useful. If I was there in person, I could do my best to answer any questions you might have. But since I'm not, I'll have to wrap it up here. Thank you for giving me the time to talk about ISTA's Responsible Packaging by Design process. I appreciate you including me in the K Forum program. I hope you have a great rest of your day.